The diagram shows a cylinder inside a cone on a horizontal base. The cone and the cylinder have the same vertical axis. The base of the cylinder lies on the base of the cone. The circumference of the top face of the cylinder touches the curved surface area of the cone. The height of the cone is 12 centimetres. The radius of the base of the cone is 4 centimetres. Work out the curved surface area of the cone. We can see we're given a formula here for the curved surface area of the cone. It's pi times the radius times L. Now we know what the radius is already. It's 4. We don't yet know what L is. L is the slanted length there. But that's okay because we can work out that pretty easily because you see we've got a right angle triangle here. I'll draw this out separately. We've got a right angle triangle where we know that's 4 and we know the height is 12. We can do a bit of Pythagoras to work out what L is. So 12 squared plus 4 squared is going to equal to L squared. So if we do 12 squared plus 4 squared, that's L squared. Square root that. So L is that. So the curved surface area, I'll just call it A for want of a better term, is pi times 4, remember that's the radius, times the answer L that I've still got on my calculator here. So pi, so I'll go shift pi times 4 times the answer pi RL to 3 significant figures. The third significant figure there is 8. The number after that's a 9, so I'm going to round up. So 159. Okay, part B. The cylinder has got radius R and volume V. We need to show that V is given by 12 pi r squared minus 3 pi r cubed. Now we know that the volume of a cylinder is usually given by pi r squared multiplied by the height. Now notice that there is no height here. So we need to somehow turn this formula into this formula by removing the h. This is what we know. This is the formula we usually use all the time. And we're going to use this but get rid of the h to get this. To get rid of that h, we need to go back and look at this diagram over here, which is why I tried not to draw on this too much. This is the height here that we need to work out, the height of the cylinder. Or rather, not necessarily work out, but get an expression for to replace here. This is what I need to replace because there's no h here. Now, if you look at this carefully, you can see that we have got two similar triangles. There is a right angle triangle here. Let me draw this out separately down here. So this right angle triangle I've just drawn, we've got the radius of the cone, sorry, the radius of the cylinder, which I know is r. So this is r. And I'm not sure exactly what this length here is at the moment, but I know that the whole height here was 12. And if this is h, then this is going to be 12 minus h. Because let me repeat that. This is 12, this is h, so this bit is going to be 12 take away h. So this is this right angle triangle. And then I've also got this bigger right angle triangle where the whole height here is 12 and the radius here is 4. And these are our similar triangles. This triangle here, this triangle here. What that does is it allows me to write down, because they're similar, I know the ratio of these triangles is going to be equal, these lengths are going to be equal to each other. So I can say that R divided by 12 over 12 minus H, this divided by this, is going to be equal to 4 divided by 12. The ratio of these two sides has to be the same as the ratio of these two sides because they are similar triangles. Or another way of thinking about this, because I know this angle here, I'll call it theta, is the same as this angle here, theta, because it's the same angle, it's that. Whether you're looking at this triangle or this triangle, that's the same angle. And remember, tan theta is the opposite divided by the adjacent. So tan of this angle is equal to this divided by this. And also tan of this angle is this divided by this. Therefore, that's got to be the same as that. So hopefully that's clear. Anyway, the point of doing all of this is it will allow me to make H the subject. Let me make H the subject of all of this. So we'll have, let's move the 12 up there. So I get 12R. And let's move all of that up there. So I get 4 lots of 12 minus H. So 12R equals 4 times 12 is 48. 4 times minus H is minus 4H. Let's move the 4, let's make that a positive over this side and move the 12R over that side. So I get 4H equals 48 minus 12R. I can divide both sides by 4. So H is equal to 12 minus 3R. And now I've got an expression for H. So I can take all of that and use it to replace the H there. So V equals pi r squared multiplied by 12 minus 3r. Pi r squared times 12 is 12 pi r squared. Pi r squared times minus 3r is minus 3r cubed, which was what we wanted. There we go. So a tricky question that. It's actually a skill, this is actually a skill used quite often at A-levels, so it's quite a tricky question there. The key thing really is you're talking about the volume of a cylinder. So you should know that you're starting from this. And then it's like, I know I'm starting here and I know I've got to get to that. But what's the difference? I've got a H. I don't want a H. How can I get rid of it? Well, what is H? It's this on my diagram. And then hopefully once you start looking at the diagram, you can start to get to this point.